In this video, we're going to be taking the limits of polynomial functions. So polynomial limits are one of the easiest kinds of limits because all polynomials are continuous, which means that limit of x approaches c of f of x is equal to f of c. So what that means is that you can just sub a number directly in. So the steps in order to evaluate is you want to look at the limit x approaches c component, and then you are going to replace your x with c. Now, for example, if we have limit of x approaches 2 of 3x squared minus 5x plus 1, you're going to be subbing in x is equal to 2. Now, another thing you have to do is you always want to put parentheses around your substitutions. This is because when you have a squared number, if you have a negative 2 squared versus a just 2 squared versus that's going to give you the same thing, actually. You have 4 and 4. But if you have negative 2 cubed versus just 2 cubed, that's going to be 8. And then this is going to be negative 8. So there's a difference. Now, the next thing you want to do is you want to sub into every single y, or every single x. So when you have limit of x approaches negative 2, you're going to have x cubed plus 4x squared minus 7x plus 1. So you're going to have negative 2 cubed plus 4, negative 2 squared minus 7 times negative 2 plus 1. Also, you always want to evaluate your exponents first, which means that you have to consider order of operations, right? So you have negative 2 cubed equals negative 8. Negative 2 squared is equal to 4. So you can rewrite that as negative 8 plus 4 times 4 plus 14 plus 1. Then you also want to multiply. So then we get negative 8 plus 16 plus 14 plus 1. We get negative 8 plus 16 is equal to 8. So then we also have 22 plus 1 is equal to 23. And 8 plus 14 is 22. So that's plus 1 we had. So now let's do a full example together. If we had limit x approaches 3, 2x to the power 4 minus 5x squared plus 7x minus 9, the first thing you're going to do is you want to substitute in. So you have 2, 3 to the power 4 minus 5, 3 squared plus 7 times 3 minus 9. Then you're going to do the exponents. You have 2 times 81 minus 5 times 9 plus 21 minus 9. Then you have 162 minus 45 plus 21 minus 9. Next, we just add and subtract. We get 129. Now, let's do some more examples. For a second example, let's do limit of x approaching 3 of the function 2x to the power 4 minus 5x cubed plus 7x minus 9. So for every single place where we see x, we're just going to substitute in 3, the value that we're approaching for our limit. We have 2 times 3 to the power 4 minus 5 times 3 cubed plus 7 times 3 minus 9. 2 times 81, because 3 to the power 4 is going to be 81. And we have minus 5. 3 cubed is going to be 27. And then 7 times 3 is going to be 21 minus 9. We have 162 minus 135 plus 21 minus 9, and that's all going to equal to 39 for our final answer. For our next example, let's do limit of x approaches negative 2 of x to the power 5 plus 4x to the power 4 minus 3x to the power 2 plus 8x minus 1. So for every instance where we see x, we're going to substitute that in with negative 2. So we have negative 2 to the power 5 plus 4 times negative 2 to the power 4 minus 3 times negative 2 squared plus 8 times negative 2 minus 1. So then this simplifies down to negative 32 plus 4. Negative 2 to the power 4 is 16 minus 3, and negative 2 squared is 4. Negative 16 minus 1. This is negative 32 plus 4 times 16 is 64. Negative 3 times 4 is negative 12. We have negative 16 and negative 1. So if we just combine all of those, we're just going to get 3 for our final answer. Now for our next problem, let's do limit of x approaches 4 times negative 3x to the power of 3 plus 2x squared minus 5x plus 11. So we have negative 3 times 4 cubed plus 2 times 4 squared minus 5 times 4 plus 11. And here we get negative 3 times 64, and plus 2 times 16 minus 20 plus 11. Next, we get negative 192 plus 32 minus 20 plus 11. And if you add those together, you're going to get negative 169. For our next example, let's do the limit of x approaches negative 1 for the function 6x to the power of 6 minus 2x to the power of 5 minus 9x plus 4. So for every instance of x, we just substitute in 1. We have 6 times negative 1 to the power of 6 minus 2, negative 1 to the 5, plus 3 times negative 1 to the power of 3, negative 9, negative 1 plus 4. So we're just evaluating, right? So 6, that becomes 1 minus 2, negative 1 plus 3, negative 1 plus 9 plus 4. And we have 6 plus 2 minus 3 plus 9 plus 4. And adding those all together, you're going to get 18. So for our next, let's do limit of x approaches a fraction, this time 1/2, of the function 8x to the power of 4 minus 6x cubed plus 10x squared minus 4x plus 7. So we're just going to, for the same process, we're going to take all of our x's and we're going to substitute in 1/2 instead. We have 8 times 1/2 to the power of 4 minus 6 times 1/2 to the power of 3 plus 10 times 1/2 squared minus 4 times 1/2 plus 7. And that's going to be 8 times 1 over 16, because we're just going to raise 2 to the power of 4, minus 6 times 1 to the power of 8 plus 10 times 1 over 4 minus 2 plus 7. We get 1/2 minus 3 over 4 plus 5 over 2 minus 2 plus 7. And that is 2 over 4 minus 3 over 4 plus 10 over 4 minus 8 over 4 plus 28 over 4. Giving us, if you add those all together, you get 2 minus 3 plus 10 minus 8 plus 28. That's going to be 29 over 4. Now, for our next problem, let's do the limit of x approaches negative 3 for x to the power of 4 minus 2x cubed plus 5x squared minus 7x plus 10. So you are going to have, for every one of your x's, you substitute in negative 3. That is negative 3 to the power of 4 minus 2, negative 3 to the power of 3, plus 5 times negative 3 squared minus 7 times negative 3 plus 10. You get 81 minus 2 times negative 27 plus 5 times 9 plus 21 plus 10. You get 81 plus 54 plus 45 plus 21 plus 10. And adding those all together, you would get 211. So this process is pretty systematic. You just substitute in for all of you substitute in the value that you're approaching with that value for every single instance of x in your equation or function. So now let's do a seventh example. We have limit of x approaches to 5x to the power of 5 minus 4x to the power of 4 plus 3x cubed minus 2x squared plus x minus 6. So again, for all of our x's, we just sub in 2. We have 5 times 2 to the power of 5 minus 4 times 2 to the power of 4 plus 3 times 2 to the power of 3 minus 2 times 2 squared plus 2 minus 6. That's going to be 5 times 32 minus 4 times 16 plus 3 times 8 minus 2 times 4 plus 2 minus 6. 160 minus 64 plus 24 minus 8 plus 2 minus 6 is 108. So now let's do the limit of x approaches negative 1/2. So that is going to be 16x to the power of 4 plus 8x cubed minus 4x squared plus 6x minus 9. So we're substituting all of our x's with negative 1/2. We have 16 negative 1/2 to the power of 4 plus 8 negative 1/2 to the power of 3 minus 4 times negative 1/2 to the power of 2 plus 6 times negative 1/2 minus 9. We get 16 times 1 over 16 plus 8 times negative 1 over 8 minus 4 times 1 over 4 minus 3 minus 9. So this is going to cancel out, this is going to cancel out, this is going to cancel out. And we get 1 minus 1 minus 1 minus 3 minus 9, which is negative 13. Let's do another example. We have limit of x approaches 5 of negative x to the power of 4 plus 6x to the power of 3 minus 11x squared plus 4x plus 20. And we are going to get negative 5 to the power of 4 plus 6 times 5 to the power of 3 minus 11 times 5 squared plus 4 times 5 plus 20. That is negative 625 plus 6 times 125 minus 11 times 25 plus 20 plus 20. We get negative 625 plus 750 minus 275 plus 40. And this is all equal to negative 110. For our final example, let's do the limit as x approaches negative 4. So we have a function 2x to the power of 5 plus x to the power of 4 minus 3x to the power of 3 plus 7x squared minus 5x plus 12. So for all of our x values, we substitute in negative 4. We have 2 times negative 4 to the power of 5 plus negative 4 to the power of 4 minus 3 times negative 4 to the power of 3 plus 7, negative 4 squared minus 5 times negative 4 plus 12. We get 2 times negative 124 plus 256 minus 3, negative 64 plus 7 times 16 plus 20 plus 12. Then 2 times negative 124, that's negative 248. We have 256 still. And then negative 3 times negative 64 is positive 192. We have 7 times 16 is 112. And we have 20 plus 12. So if you add all this together, you're going to get negative 1,456. So remember that your polynomial limits are continuous, meaning that you can always just plug in the x value. So it's just a matter of evaluating.